Hello everyone, welcome to our vlog, and we'll be talking about modular arithmetic. I am Hugh Franco Estrada, and my group mates are Christian Bustamante and Andrew Bugas. And we'll be talking about modular arithmetic, specifically mathematics in the modern world. Let's get right into it.
So, why do we consider math is basically important for us? So, to answer that one, math itself is important because it is what drives society to work, to understand the entire world, to provide an effective way of building a mental discipline where it's logical reasoning, critical thinking, and spatial thinking for us, and its application in all things we interact and is used in a daily basis in our lives. So to rather expound on this one, we can certainly say math is basically part in our world, that its application and its outputs are here that we see. The example, a cell phone there, it is made of materials that are specified according to the mathematical proportions, and its chips there, their integers are correct, that are set accordingly, and what makes it run. And what do we so to say, like, we think critically, that is rather we think intellectually to solve basic math problems that we encountered in this daily life, that we encountered, that is, we use our minds, and where we create this somewhat logic, where we actually identify the logical problem in a mathematical point of view that we answered. Without math, the society itself would become a problem. It would become a pointless society because people would have a hard time having a possibility. And thus, mathematics itself is important because it gives important applications in life, and it's what drives what society works, that are based on formulas, the truth that is obtained from the solving of its question, and its structure.
Now that Andrew discussed on the importance of mathematics, especially in the modern world and its applications, let's talk about modular arithmetic, because this is basically what the vlog is all about. Modular arithmetic, by its definition, is a system of arithmetic for integers which considers a remainder. And this definition is taken from brilliant.org. So, before proceeding, let's talk about how there's this common perception of thinking that math is something that won't be used in the future, something that, oh, if I'm going to be a politician, I wouldn't have to learn geometry, for example. But this is a false perception, because math is inevitably something that is useful, something that is relevant, and we see this in modular arithmetic and in real-life application. For example, when determining a specific time, when given the number of hours from a specific time. It also applies in validating a credit card number. It also applies in the UPC, verifying the universal product code.
Good morning, everyone, and today I will be discussing ISBN. What is ISBN exactly? ISBN is International Standard Book Number, which is a numeric number, commercial book identifier. To put this in simpler terms, you can find this in your book. Specify, here is your ISBN number. It is an example of where you can find your ISBN number. It is always sometimes at the back and sometimes it's front, but normally it's always at the back. It is intended for it to be unique. It is assigned in different types of agencies to make sure that the books have different types of numbers, and each one of it has its own unique number, a corresponding number. Why does this to imply this in our daily life? To imply this in our life, not daily. Specifically to know whether the book is what kind of book you are finding. You can just look at it. You can sometimes look it up in a website where it can search ISBN, the ISBN. The number also helps us figure out which type of country it came from. It can indicate what the publisher, the title of the book, and the last number is usually called the check digit. It is used to know if the barcode has been entered correctly. Because if the barcode is wrong, then it would show incorrect. So the book is not properly published. It's used to make the books unique and less complicated in finding, and so it would be sorted out correspondingly. We find this in books because people place them for exact reasons, so we wouldn't be confused whether it came from or whether what the publisher is or what the title of the book is. Secondly, this was put together so that it would be easier to find out which is which, so we won't be confused less, and it would bring much about everything together. We would just put everything in order because there's so many books in the world, to be exact, and for that to happen, for that to not be like confusing, it would be a disorder. This is a way to disorder things, ISBN. Now we will move on to our next topic. What is our next topic? Our next topic is UPC. UPC stands for Universal Product Code. This is so much similar to the ISBN code, but instead of books, it uses for example, it is for products that you can find in your supermarket or grocery stores, the one that they use to scan. It's being used almost nationwide because of the vast majority of products that are in, and it's very hard to put them in order, so people use codes so it could be properly placed in order, and so that you could finally you could find out the price much more easily rather than just searching for how much the product costs. So you just scan it and boom, there it goes. This is used to identify what the product is. Sometimes it's about the cash, it's about how much product they're in their stock, or they ran out of stock. This is used in products that we daily buy on a daily basis. The products is what the use of UPC is. It makes things easier, such as this product here, my lotion. It has a UPC here. That's the UPC code. It's a universal product code that they scan in order to look up how much it is, and it is registered in their cashier. That's how they know how much a product costs and how much a product has been discounted. This is what makes it so useful to us human beings. So we would get things in order rather than disorder. This is crucial to every grocery store or supermarkets because it would help them much more faster, and they can update the prices much easier rather than placing it one by one on each product they have. This will make things easier by just putting the code in and just updating it to its price. That's why it is a necessity to companies that bring out products such as Coke. This is why it is very important to use UPC.
For the next part of the video, let's talk about credit card numbers. More specifically, in validating credit card numbers. Why do we even need to validate credit card numbers, Hugh? That is because we need it for security reasons, for example. We need it to know that this credit card is authentic. And this is money that we're talking about. So that is why it's so important to validate credit card numbers, because it's something that is a part of our personal lives, for our personal livelihoods, for example. So here are the steps for validating credit card number. Firstly, we read the credit card number from right to left, and then we double every other digit. Second step is that we get the sum of those double digits, or the digits in the credit card. And next, we check if the sum is 0 in modular 10. So let's try it right now. Okay, so let's try validating a credit card number. So here is our credit card number. Before I'd like to start with the steps, I'd like to count first how many digits there are, because usually credit card numbers fall around 13 to 16 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 16 digits, meaning it is a credit card number, but let's first verify if it really is a credit card number. So we read from right to left, and then we check the every other digit, and then we double it. I will fast forward. If you've noticed, when we doubled 5, it became 10. And if you're wondering, we add 10 to 1, 2, 3, 1, 2, 2, for example. No, we treat these as singular digits. So now we add all these digits together. This is how we're going to add these digits. Again, we treat these digits as singular digits, not as 10. So 1 plus 4. Now that we have got the sum of all the double digits, it is equal to 43. But 43 modulo 10 has a remainder of 3. And according to the third step, check if the sum is 0 in modulo 10. Because if the sum is 0 in modulo 10, it means it is a verified, a valid credit card number. But since it is not 0 in modulo 10, because it has a remainder of 3, it is not a valid credit card number.
So on cryptology. The cryptology itself, rather, when we define what cryptology is, it rather hides data behind encryption. Rather, it involves in storing secret information with a key or a code that people must have required in order to access or to obtain that raw data, where it encrypts said text and it becomes secret through encryption. For those who access it without understanding its numerical value, they would rather certainly see only nonsensical text because they didn't have access to that specific key, and they would have a hard time. But in contrast, a person that has the access to those keys, then that encrypted data would be accessed. It would be accessed accessibly and is safe. So meaning to say that rather with cryptology, our data will be kept confidential through security measures. So to rather certainly explain examples of cryptology, we first and foremost we got public key cryptology. What is that? It's where the sender only uses public information, where the receiver has a secret key. That is after when he got the item from the sender. It is discovered in the 1970s by many mathematicians. But advances in cryptanalysis rather are dramatic, and so the integers are much more larger than originally envisaged. So the second is elliptic curve cryptography. The idea was that it would resist sub-exponential index calculus algorithms and would be more efficient. It is essentially viewed as a much more form of advanced mathematics that is to be used in cryptology, and is now considered a very mature field and widely used in the whole cryptology world. With these applications in cryptology, math was able to generate more encrypted text that are harder to decode without complex and also encrypting hard encrypted messages. One example of this application of cryptology through math is the Bletchley Park in Great Britain, where one of the Colossus, one of the first programmable computers, was able to decipher the German intelligence messages, which the Allies used to great effect in discovering German secret messages, which they used to their advantage to defeat Germany in World War II. It is rather especially thanks to Alan Turing for that contribution. That what makes Bletchley Park a very effective way of, say, cryptology.